Okay, so imagine this, a programming language that doesn't just follow the rules. It can actually understand them, question them, and yeah, even rewrite them. That's pretty wild, right? Well, that's the core idea behind something in computer science called rewriting logic. It's a framework that kind of forces us to rethink what computation is all about. So let's dive in and see how this thing works.
So here's the massive challenge we're facing. I mean, think about it. You've got all these different programming languages, all these systems out there, and every single one has its own unique rulebook. How in the world do you get them to talk to each other? And even tougher, how do you get one system to understand the actual logic of another? This is exactly the kind of problem rewriting logic was designed to tackle head on. Now, to solve a problem that big, you're going to need more than just another programming language. No, you need something much bigger, a universal framework. You can kind of think of it like a Rosetta Stone, but for code. It's this common language that lets all these different systems not just, send messages back and forth, but actually understand each other on a deep level. And just so we're clear, rewriting logic isn't some obscure niche thing tucked away in a corner of computer science. No way. This belongs in the big leagues, right up there with the heavy hitters like first-order logic and logic programming. The fact that it's even on this list, well, that tells you just how foundational this idea really is. All right, so we get that it's a big deal, but what is rewriting logic really? Let's break it down.
Okay, so at its core, rewriting logic is a formal system. But, and this is a huge but, it's not a passive one. The magic word here is executing. See, it's not just about describing a system on paper, it's about actually running it. It's this active, living framework that brings these systems to life and that lets us check them out and reason about them in a way that's totally dynamic.
And yeah, it's got some seriously impressive moves. It can handle these ridiculously complex systems. It's great at modeling concurrency, when a bunch of things are happening all at once. And it's a rock-solid base for making sure your code actually does what you think it does. But its real superpower, the thing that makes it a total game changer, is this last one right here, a unique capability called reflection. Okay, now this is where things get really cool. Reflection, this is the secret sauce. This is what makes rewriting logic so incredibly powerful. It's what gives it the ability to be, well, kind of self-aware. We're talking about a logic that can literally think about its own rulebook. I know, that quote sounds a bit academic. So let's just translate that. Meta theory, that's just a fancy term for the rules about the rules. So basically, a logic is reflective if it can use its own language to talk about its own internal rulebook. Simple as that. Let's make it even simpler. Think about a chess AI. A normal one knows the moves, right? A knight moves in an L shape, a bishop on the diagonal. But a reflective chess AI, it understands the idea of the rules of chess. It gets why checkmate is the goal. It can actually reason about the rules themselves. That's reflection right there. So how does this actually work under the hood? Well, it all starts with this really clever trick. You treat the system's own rules as just data. That's the key. Once the rules are no different from any other piece of data, the system can create what are called internal strategies to mess with them. And these strategies are what give the system the incredible power to guide its own thinking, to actually control how it reasons about things. Now, I know this might all sound super abstract, like something you'd find in a textbook, but it is absolutely not just a theory. It's been brought to life in a really powerful system called Maude. And Maude is what takes this reflective logic and turns it into a tool you can actually use. So what is Maude? Well, it's a high-performance language that's built from the ground up on the principles of rewriting logic. It's the thing that takes all of this mind-bending reflective power and puts it into a package that developers and computer scientists can actually get their hands on and build with. And once you have Maude, the possibilities just explode. I mean, because it's reflective, you can do things like build a programming language inside another programming language. You can define and run entire logics all within the Maude framework. Or you can build these super specialized tools like theorem provers designed for one very specific, very hard problem. Okay, so what's the big payoff? Why do we care about all this self-awareness stuff? Well, it comes down to this. It lets us tackle problems that are so massive, so unbelievably complex, that our traditional methods just throw their hands up and quit. One of the biggest nightmares in all of computer science is a problem called search space explosion. This is what happens when a program has to look for a solution and the number of possibilities just explodes. It's astronomical.
It's like being dropped into a forest where every path you take splits into a million new paths forever. You're just completely lost. And this chart right here, it really says it all. Look at that massive bar for classical methods. That's the gigantic search space they have to wander through. But with rewriting logic, the system can use those internal strategies we talked about to be way smarter. It can look ahead and say, nope, that entire branch of the forest is a dead end, and just chop it off. It completely prunes the search, which drastically cuts down the work. So the key thing to get here is that this isn't just about being a little bit faster. This is about making the impossible possible. I mean, there were problems in database theory, for example, that were just considered unsolvable because of this search space explosion. But with Maude, researchers can use these internal strategies to find solutions. It literally turns an intractable problem into one we can actually solve. All right, so let's pull this all together. What are the key takeaways? First, rewriting logic is this universal framework for computation. Second, its superpower is reflection, this amazing ability to reason about its own rules. Third, that superpower lets it solve these ridiculously complex problems by controlling its own thinking. And finally, the language Maude is what brings all this power out of theory and into the real world.
And all of this leaves us with a pretty fascinating question to chew on, right? We've just seen how a formal logic can have this kind of self-awareness. So as we keep pushing the boundaries of AI, what could true self-awareness in a machine even look like? And you have to wonder, could these very ideas from rewriting logic be one of the key stepping stones on the path to figuring that out? Thanks for diving into this with us.